Today we're taking a look at two more identities. These are the sum identities for sine and cosine, the sum of angles identities for sine and cosine. So there are definitely proofs of these, but they are a little bit too long to do in class, so I'm not going to do them in class. I did find a nice proof of the sum of sine for the sine formula on YouTube, and I'm sure that there are plenty for cosine as well. But if you're interested, there's a little QR code that will send you to YouTube for a nice proof for this identity. But like I said, I'm not going to do it in class. All I'm going to do is I'm going to give it to you along with a way to remember it. So we've already had a few identities. You have your reciprocal, your quotient, and your Pythagorean identities, and today we're doing the sum of angles identities. Two new identities for today. Tomorrow we'll get a double angle identity. So, and then that'll be it for the identities to memorize. Alrighty, so sum of angles for sine. So we're talking about sine of the sum of two angles. I'm going to call this A plus B. You could call it alpha plus omega, you could call it theta plus beta, whatever. You could call it x plus y if you want to. I'm just going to call it A plus B. And the way that we find that is we start with sine of A. Then you multiply sine of A times cosine of B. And then you add the other set. So sine of A plus cosine of B plus, now you need sine of B multiplied by cosine of A. And that is the formula for the sum of angles for sine. For cosine, so we're talking about cosine of A plus B, two angles. So to find the cosine of the sum of angles, you start with cosine of A. Alright, it's cosine of A times cosine of B. So it's two cosines together. It's common for kids to want to put a plus here, but it's not a plus, it's a minus. So even though there's a plus here, the formula for this has a minus there. And then you do the sine ones. Sine of A times sine of B. And that is the formula for the cosine of the sum of angles. Alright, so take a good look at them because we're going to need to memorize those. If you do enough problems, you won't have to work at memorizing those. It will just come naturally. We are not going to memorize any more sum or difference identities, because there are ways to get there. If you're asked to find tangent of a sum, you just find sine over and then put it over cosine of that sum. If you're asked to find cosecant, then you just do find sine and do the reciprocal of it. Okay? If you're asked to find a difference, A minus B, don't memorize a new formula. Instead, just make it plus the negative, and then use the same formula with the negative of B rather than positive of B. So let's do some examples. Number one, let's determine the exact value of cosine of 5 pi over 12. 5 pi over 12 is not one of our memorized unit circle values, right? So we need to use one of our sum formulas. So it's a cosine, so I'm definitely going to be using a cosine. Okay, I need two known angles that add to 5 pi over 12. Well, 5 pi over 12 is 3 pi over 12 plus 2 pi over 12. Why did I choose those two? Why didn't I choose 4 pi over 12 plus 1 pi over 12? Because 3 over 12 can be reduced, and 2 over 12 can be reduced. They can both be reduced, and they can both be reduced to pieces that we know. We know cosine and sine of pi over 4. and we know cosine and sine of pi over 6. So you're going to be breaking this up into two angles. And those two angles you need to know, they need to be your unit circle values that you know. Pi over 3, pi over 6, pi over 4, pi, 3 pi over 2, those ones that you know. Alright, so now I can come down here and say, alright, so now I know cosine of 5 pi over 12 is equal to this, and I'm going to use my cosine of the sum of angles formula. And for that one, I start with cosine. Cosine starts with cosine. Oops. Not a 5. Cosine of the first one times cosine of the second one. The formula has a minus. Now do sine of both of those. Sine of the first one times sine of the second one. Almost there. Cosine of pi over 4 is square root 2 over 2. Cosine of pi over 6, square root 3 over 2. Sine of pi over 4, square root 2 over 2. Sine of pi over 6, 1/2. Since we know these unit circle values extraordinarily well, we just spit those out. Square root of 2 times square root of 3 is square root of 6. 2 times 2 is 4. Square root of 2 times 1 is square root of 2. 2 times 2 is 4. Write this as a common denominator. Square root of 6 minus square root of 2 all over 4. That would be the multiple choice answer. Let's do another one. Determine the exact value of sine of 17 pi over 12. So we're going to begin by splitting this up, splitting 17 pi over 12 into two fractions that add or subtract to 17 pi over 12, both of which can be reduced to fractions that we know the sine and cosine of. So 17 over 12. Let's see, there are several that I think would work. Actually, I know that there are several that would work. 15 and 2 both reduce with the 12 and add to the 17. 14 and 3, those both would work as well. I tend to like to go a little bit more middle of the road, so I think I'm going to do like 9 and 8. 9 and 8 both reduce with 12. So I'm going to call this 9 pi over 12 plus 8 pi over 12. There are plenty more to do that we could have done, but these work for me, so I'm going to do that. So these both reduce. 9 pi over 12 reduces to 3 pi over 4. 8 pi over 12 reduces to 2 pi over 3. Sorry, took a 4 out. Okay, 2 pi over 3. So I have sine of the sum of two angles, both of which we know the sine and cosine for. So sine of 17 pi over 12 is equal to, so it's a sine, I'm using the sine sum of angles formula. So I start with sine. Sine of the first. Not that it matters in this case because there's a plus in between here, but I always do sine of the first first. If it's sine, I do sine, and I just do the first one. Then it's cosine of the second one. Plus is in the formula, and now it's the other ones. So sine of the second one times cosine of the first one. And now we find these values. Sine of 3 pi over 4, second quadrant, sine is positive. Cosine of 2 pi over 3, second quadrant, cosine is negative, that's a 1/2. Sine of 2 pi over 3, second quadrant, sine there is square root 3 over 2. Cosine 3 pi over 4, that's second quadrant, so negative square root 2 over 2. This is negative square root 2 over 4 minus square root 6 over 4. Multiple choice answer, they might have it like this. Or they might pull out that negative way out in front of the entire fraction and write their answer like that. Both of those are eligible multiple choice answers. Okay, let's do another one. Let's determine the exact value of sine of pi over 12. Sine of pi over 12. Notice that my denominators have 12s. It's because they reduce nicely and get 4s, 3s, and 6s. So no need to go crazy with these. In AP Classroom, I noticed that they did not go crazy with them. They kept the denominators 12 as well. Okay, sine of pi over 12. Well, I'm definitely going to have to subtract to get to a 1 over 12. True? And there are lots of things that would work here. I'm going to keep it the lowest I can. I'm going to make it like a 3 minus 2. So 3 over 12 minus 2 over 12. So 3 pi over 12 minus 2 pi over 12 is 1 pi over 12. And these both reduce nicely to pi over 4 and pi over 6. Now this is a minus, so I'm applying that to this pi over 6. I'm making it plus a negative pi over 6. So sine of pi over 12 will be, it's a sine, so start with sine of the first thing. Okay? And then cosine of the second one. And just remember to apply that negative to that angle. Plus, now switch them, sine of the second one and cosine of the first one. Sine of pi over 4 is square root 2 over 2. Cosine of a negative pi over 6. Negative pi over 6 is down in quadrant 4, where cosine is positive. So this is a positive square root 3 over 2. Sine of negative pi over 6. Negative pi over 6 is in quadrant 4, where sine is negative, and that will be a negative 1/2. Cosine pi over 4 is square root 2 over 2. This is square root 6 over 4 minus square root 2 over 4. So that is square root of 6 minus square root of 2 all over 4. Multiple choice answer right there. Okay, what if they have a secant? Well, secant is 1 over cosine. So I'm going to first find cosine and then take the reciprocal of it to get my secant. So cosine of negative pi over 12 is cosine of, all right, I think I'm just going to go backwards. I think I'm going to go 2 pi over 12 minus 3 pi over 12, and that is negative pi over 12, right? So this is cosine of pi over 6 minus pi over 4. Once again, this negative, I'm applying it to the second one. I'm making it plus a negative pi over 4. So cosine of negative pi over 12 is cosine of the first times cosine of the second. Minus is in the formula. Sine of the first times sine of the second. Cosine of pi over 6, square root 3 over 2. Cosine of negative pi over 4, positive square root 2 over 2, that's in quadrant 4. Sine of pi over 6, or 1/2. Sine of a negative pi over 4, quadrant 4, sine is negative. So this is square root of 6 over 4 plus square root of 2 over 4, which is square root of 6 plus square root of 2 all over 4. I definitely write it like that here because I'm not done yet. So secant of negative pi over 12 will be the reciprocal of cosine of negative pi over 12. So the reciprocal of that is 4 over square root of 6 plus square root of 2. That will not be the multiple choice answer. To get the multiple choice answer, they will rationalize the denominator by multiplying top and bottom by the conjugate. and we will get 4 times square root of 6 minus square root of 2 divided by square root of 6 times square root of 6 is 6. The middle term zeroes out, minus square root of 2 times square root of 2 is 2. This is 4 times square root of 6 minus square root of 2 all over 4, which is square root of 6 minus square root of 2. Secant of negative pi over 12. Let's do a quick check. Okay. Secant of negative pi over 12 is 1 divided by cosine of negative pi over 12. Square root of 6 minus square root of 2. They match. They should match because they're the same. Alrighty. One more. Given to us in a different way. Given that tangent of u is negative 4 over 3 and that u is in quadrant 2 and cosine of v is negative 12 over 13 and v is in quadrant 3. What is the exact value of tangent of u plus v? Alright, well, I know tangent of u plus v is sine of u plus v divided by cosine of u plus v. So I need to find sine of u plus v and cosine of u plus v. Divide them, we'll have tangent. Alright, so I'm going to use my information about u. U is in quadrant 2. So there is u. There's angle u right there. The reference angle for u is right there, but u is right there. It's in quadrant 2. It terminates in quadrant 2. Tangent is negative 4 over 3. That's opposite over adjacent. 4 over 3 with the 3 being negative because it's in the negative x direction. The hypotenuse, that's a special right triangle, 3, 4, 5 right triangle. So that is the picture of angle u. Sine of u is 4 over 5. Cosine of u is negative 3 over 5. Now I'm going to do the same thing for v. V is in quadrant 3. So there's v. There's the reference angle for v. Cosine of v is negative 12 over 13. That's adjacent over hypotenuse. Negative 12 is adjacent. Hypotenuse is 13. This is a 5, 12, 13 right triangle. The 5 is also negative because it's going down, negative y direction. So sine of v is negative 5 over 13, opposite over hypotenuse. Cosine of v, we were given, but that is negative 12 over 13. Okay, so I have cosine and sine for both u and v, so I can very easily get sine over cosine of u plus v. So let's do that. So I'm going to do sine first. So sine of u plus v is sine of u cosine of v plus sine of v cosine of u. Sine of u is 4/5. Cosine of v is negative 12/13. Sine of v is negative 5 over 13. Cosine of u is negative 3/5. So this is negative 48 over 65 plus 15 over 65. And that is negative 33 over 65. So that's sine of u plus v. Now we're going to find cosine. Cosine of u plus v is cosine of u cosine of v, minus sine of u, sine of v. Cosine of u is negative 3/5. Cosine of v is negative 12 over 13. Sine of u is 4/5. Sine of v, negative 5 over 13. So this ends up being 36 over 65 plus 20 over 65, which is 56 over 65. Therefore, tangent of u plus v is sine of u plus v, which was negative 33 over 65, divided by cosine of u plus v, which was 56 over 65. They both have denominators of 65. If you multiply top and bottom by 65, the 65's disappear, and we get negative 33 over 56. That's tangent of u plus v. Okay, and that is the identities for sine and cosine of the sum of angles.